Hello everyone. This is Gayatri Priya, Assistant Professor in the Department of ECE of RMD Engineering College. In today's session, we are just going to discuss about ratioed logic circuit. So, what are the features of ratioed logic circuits? We have already discussed about the CMOS circuits. That is, we will be having a pull-up and a pull-down network. Here, we are just going to cut off the pull-up network. That is, we are just going to reduce the number of transistors and thereby we are just going to reduce the robustness. So as discussed, we will be having a pull-up network as the PMOS transistor and the pull-down network as the NMOS transistors. Let us see to the types of ratioed logic circuit. The first one is going to be the generic circuit. The second one is the pseudo NMOS circuit. So, what's the difference in the sense? As mentioned already, we are just cancelling out the pull up devices. That is, no PMAS is being connected. In the place of PMAS, we are just replacing it by a single load. Okay, the supply is given and it is being connected to the pull down network, which is nothing but the NMOS transistor. For example, here we have taken a three input logic, right? Instead of connecting the pull up PMOS transistor, we are just replacing it by a single load. That is your generic circuit. The same circuit, if I am going to replace this load by a PMOS transistor, then that is called your pseudo NMOS circuit. Here you could see the entire pull-up network. Even though we are having n number of inputs for that pull-up network, we are just going to connect only one PMOS transistor. That too, the gate terminal is being grounded, thereby making always this PMOS load should be an active load and will be having a intense effect only because of this pull down, that is the NMOS circuits, and that's why it's being given the name as pseudo NMOS circuit. Let us take an example of 4 input NAND logic. Okay, so this is the generalized CMOS logic. Here we have taken 4 PMOS transistor which are connected in parallel as the pull-up network. Similarly, in the pull-down network, we are having 4 numbers of transistors, that are NMOS transistors are being connected. The inputs are A, B, C, D. Okay, so this source is being given the supply VDD and this source is being grounded, right? The junction of the drain of both pull up and pull down is being taken at the drain and it is taken as your output. This is the generalized CMOS 4 input NAND logic. Let us see to the pseudo NMOS logic of the same 4 input NAND. What we have done? We have given the inputs as usual, that is we have taken 4 NMOS transistor. For the 4 NMOS transistor, the inputs are terminated as A, B, C, D. In the place of 4 numbers of PMOS transistor, that is this pull-up network is entirely replaced by a single PMOS transistor. That too, the gate terminal is grounded. That is, we have connected a single PMOS load along with the NMOS transistor. By doing so, what we are doing? We are reducing the number of transistor in order to reduce the robustness. Hope you understand this session. The same category of logic can be applied for anything. For example, we can apply for 4 input NOR, or you can take any boolean expressions and you can do that the ratioed logic in both generic as well as pseudo inverse. Thank you.